Welcome everybody to our webinar today, all about ducted heat pumps as a furnace replacement, talking more about how you use a ducted heat pump for a retrofit of your existing home. A few housekeeping items. We will be recording this, so the recording will be available later, and within the next week or so, we'll email that out along with these slides. We would love for you to ask questions to Dave, so please put your questions specifically in that Q&A box if you can, and then Diego and Mary will make sure all those questions get asked to Dave, and Dave will answer them after he's done. His presentation, I think, is around 20-25 minutes today, so we'll have plenty of time for questions afterwards, and we will go ahead and get started. But first, let me tell you a little bit about Dave. David Petroy, he has over 15 years of experience in a range of renewable energy, sustainability, and business roles. He was the founder and the president of Blue Valley Energy. It was a successful ground source heat pump engineering, design, and installation company in Boulder. They did over 200 installations throughout Colorado. During the early 2000s, he led technical sales of solar and energy power systems for residential and small commercial businesses. Most recently, he was the sustainability manager for Golden Aluminum, one of the largest single-site industrial power users in Colorado. And in 2017, he launched NTS Energy. This is what he's currently doing, and it's a consulting company focused on providing advanced HVAC and solar solutions to homeowners and small processes. In 27, I can't read, boy, to homeowners and small commercial companies, and promoting the transition to a new energy economy in Colorado. Dave holds an MS in geophysics and a BS in zoology. Thank you, Dave, for being here. You can tell us all about zoology later, but we look forward to you telling us all about your expertise about heat pumps for ducted homes.
Thanks, Nikki. So just the heat pumps, usually you can't find an exciting picture, but these are seasons up in your beautiful part of the country. And so we're going to talk about the versatility of heat pumps to be able to heat in all of these seasons. So let's go to the first slide. We don't need to, I can read about me later. We're going to talk about how heat pumps work. We're going to talk, one of the most exciting parts is how they've advanced over the last 15 years. I'm going to talk about replacing your system with a heat pump strategy. How do you acquire a good system? And we'll layer in rebates and programs and incentives. So I'm going to just quickly go through what is a heat pump for those of you who don't know. And you have to think of it as it moves heat. It doesn't create heat. It doesn't move temperature. So even in the cold air outside, there's still lots of heat in the air at -10. Only at -460 is there no heat. Air conditioner is just a one-way heat pump. So this just gives you, this is a very brief, and I'll just go through this a little bit quickly. So inside your house, what you have is in the case of a ducted system, an air handler or a furnace, which is mostly used as an air handler in conjunction with the heat pump. Or this is in the mini split scenario. And though this talk isn't about mini splits, I will touch on those in a couple slides. And then outdoor, you have a unit, like I said, looks like an air conditioner. It just has a reversing valve and goes both ways. And this is a mini split ductless system, and they basically the same strategy, they just have a little bit different shape. So what happens in here on the outside unit, you're blowing air by it, and refrigerant is inside. Refrigerant has this amazing property, it loves to absorb heat. So it absorbs a lot of heat, though it's not super warm, but it comes into a compressor. This is where they add a little energy, it compresses it, heats it up to about 110 degrees. It comes in, air goes by in the case of ducted system, and it heats your home and goes back in the cycle, repeats itself. So one thing, notice when the air comes out, you'll notice with a heat pump, your duct, when you put your hands over it, it's about 95 degrees. It's not going to be super hot like a furnace, for example. It's just going to feel neutral to the skin, but 95 is much higher than 75. We want to heat our, or 72 or 70 want to heat our homes, so it's still plenty of heat. So let's just talk really quickly here about how much, just the dramatic improvement, and actually that's why we're all here. Around the early part of the 2000s, I'm saying this was kind of birth of the cold climate heat pumps in North America. There had been some work in Japan and Europe on them, but really up in New England, oil heating prices went up. And researchers always said there was no real reason in the physics why heat pumps can't work when it's really cold. So there was a lot of efforts in defrosting, making them work cold, and keeping capacity for several years. And then over the last 10 years or so, they've been installed throughout North America. Like I said, longer in other parts of the world, but in cold climates, Canada, the upper Midwest, New England, everywhere. So this is in a way new, but in a way not so new anymore. And what happened? Well, the cool thing is there's everything inside the engineers can work on. And I'll just briefly touch. The main thing are two. The compressors got a lot better. So the ability, it used to be compressors on, off, on, off. And now they're variable speed. So they can just put out as much heat as we need. It doesn't, so you're very miserly on the energy. The second thing is really computer control. So basically you can now, the computer senses, you got your thermostat, it says, I need to increase the heat by a couple degrees. It kind of knows what the outdoor temperature, it basically talks to the compressor, talks to the system. Compressor works just what it needs, but it also matches with the indoor unit. So the indoor fan or air handler isn't blasting, it's just running just what you need. And one thing about heat pumps is you just kind of set them and go. They like to keep the house at a constant temperature. It's not so much on, off, on, off. So that was some of the stuff inside. So what did that do? Well, it did two really big things. Well, three actually. First one here, this bottom is the outdoor temperature. So 0's on the left, cold's on the left, and 60, warm is on the right. And this is the amount of heat your house needs to heat. And this green line is kind of a typical house. It says, all right, I need more and more heat as it gets colder. And this is what happened with this improvement. This thin blue line here used to be how much a heat pump could put out. And notice that it was around 30 degrees. And so heat pumps really were just for the South. They just set them up and said, if it's above 32, okay, you can use a heat pump. Well, over time, kept working on this, working on it. And now the cold climate heat pumps, they're able to hold their capacity. So notice way down around 15, 10 degrees, the crossover point. Now you have this little wedge, and it's a little bit bigger out here. This little wedge of heating is done by the supplemental heat. So we'll talk about in the next slide or so, next two slides, that's either going to be some electric or if you've still paired it with a furnace, a little bit of gas or propane. So this is one big improvement, the ability to hold capacity and heat when it's really cold out. The second one is efficiency, which directly translates into operating costs. And so this is 2012 to 20. So this is, about 10 years. And and HSPF 0 to 14, the higher the number, the more efficient it is. It's called heating season performance factor. 8 is twice as good as 4, etc. So it was around the low 8s was typically what the manufacturer's producing. And every couple years, they have an improvement. And right now, this is 2017, 2018, and this is pretty much where we are now. In fact, I expect probably in the next 2 years, there's going to be another leap forward. This is where most of the products are manufactured. There's still some that are up around 13, but notice the improvement here is around 28% for these cold climate heat pumps. So really almost 25 to 30% improvement, which means the cost to heat your home with a heat pump is dropped by that much over time. Big, huge improvement. So those were two of the improvements. We talked about efficiencies, talked about capacities below 30, and they even have, this goes together in defrosting capabilities. So they can actually reverse when the unit starts to ice up, it reverses the heat and defrosts, and then also pressing it so that it can work well down below 0. So big 4 improvements. That's why the heat pumps work well in Colorado. So if your furnace is going out or it's time to replace, you have 2 options. One is is a heat pump system with an air handler. So you've got your heat pump outside, air handler inside. It's going to be very similar in size and shape to your furnace. Only different, it's got that fan unit in and some smart electronics. It's going to have in here a little bit of an electric coil for the supplemental. The other option is you got the same situation and you've got your furnace, which you're going to use almost all the time really as an air handler. And just when it gets to the supplemental point, you'll turn on your furnace part of it. So you've got two really good strategies here. One is if you want to tend to go all electric, and the other is if you are more comfortable keeping a little bit of the furnace. But let's take a little sidetrack for 2 slides and talk about mini split systems. So mini split ductless have a lot of applications, and last week's talk, we have a presentation we can send to you. If you want it, just please request that in the chat. But basically, you have an outdoor unit. It's a heat pump, but it's a little different. Rather than ducts, you've got refrigerant lines, and you can go to various indoor units. And these are the old style, used to be on the wall. They're still used, but now you can have ones hidden in the ceiling. You can have little duct systems above, mini ducts, etc. So there's a lot of different strategies. You can usually do up to 5 independent units, and the indoor units are very quiet. And I talked about different styles, but why am I mentioning this? Well, there's a few really nice things you can do. And last week's talk mainly focused on if you've got radiant in your home, either radiant in-floor, radiant baseboards, electric baseboards, propane, gas, whatever kind of radiant you have. And now you want some cooling in the upstairs or second floor. This is a great way to complement it. If you want to greatly reduce heating costs with electric and propane, you can do that. If you also want to cut your pollution a bit too, they will definitely do that, your GHGs. Another strategy, if you have a small home or a condo and you want to convert from these expensive fuels. And another good thing is new addition heating and cooling, no matter what your current system is. There's many advantages to that. So like I said, if you want to learn more about this, please just ask for the slide deck. So there's a lot of benefits with the heat pump technology. It uses a lot less energy, 1/3 the energy of a furnace. And the way that's described, it's pretty simple. It's called COP, or coefficient of performance. All that is, it says, for how much energy I put in, how much heating energy do I get out? And in the heat pump, it's moving heat. So I put 1 unit of electricity in, I can move 3 units of heat. A furnace at a 95% efficiency, essentially, I'm burning the 1 unit of gas or propane, I'm getting 95% out, 0.95. So much more efficient. Obviously, cooling in addition to heating. It's going to really either greatly reduce 80% plus or eliminate outdoor emissions from your home heating system. So up in your part of the state, maybe you don't have to deal with sort of the front range smog as much, but your local neighborhood, it's eliminating that. It's going to, versus propane and electric, it's going to cut your heating bill way back. With gas, you have this benefit where you can actually use more heat pump when gas prices are high. You can move it back and forth. I'll talk a little bit about that. It's really a nice hedge. And it's greatly going to reduce, contribution to sort of regional pollution, the state or whatever you consider the region, the high country. And as the grid gets greener and greener, Mary knows from Holy Crosses here, she knows all about that. They're working very hard. Great reductions in GHG. So, many benefits. It's basically a new technology. I think of it as like the cell phone replacing the old landline. So let's talk a little bit about let's just think about it in terms of seasons and how much heat. So this is a graph in Eagle, January to December, and this is, the temperatures, and you can see it. And really what you want to do is think about the heat pump is really almost 10 out of 12 months, man, the heat pump's doing all the work. And then in the coldest months, it needs a little supplemental to help do it. And so But you think, well, gosh, I use most of the heating in the cold months. That's not really true, because it's kind of funny. The number of hours that we actually spend in these different temperature bins in Colorado is a little bit surprising what it turns out to be. This is on the bottom is temperature -20 to 65. And this is the percentage of my annual energy use. And you can see above 15 degrees outdoor temperature, that's where most of my heating energy is, really right around freezing is a lot of it. And just below. I mean, certainly the cold comes in, but it's a relatively small number of hours. So really what we're doing is we're talking about heat pump working and doing all of this, working in here some, but being supplemented. A very different strategy, using the technology to its best advantage. So the bottom line is, well, how much is this all going to cost me? What's it going to save? And so this gives you an idea, and really against propane furnace and electric. If you have an electric furnace, the savings are even a 5% more. So this is like a typical house in up in the high country in Eagle. Let's see, a 4-ton, a couple thousand square feet. And this is like the annual propane heating bill. And then this would be, notice the air handler with the heat pump. And then with the propane, they both dramatically reduce it. This is very little difference. So really you could save, you're going to save, and basically cut your bill in half, a little more than half, quite a bit of savings. So down here's the savings. And now it's like, okay, well, how much more does it cost? I'll just note that, pricing for HVAC all over Colorado varies quite a bit. So we're really trying to just get it in the ballpark. If you went out and got a few bids, kind of what will be the median. So, propane furnace, and then this would be a furnace if you wanted to have cooling in your house. And then this is sort of the heat pumps with the air handler or the furnace, very close in price, just a little nuances in the difference. Fortunately, in where you live, there's fantastic support with the utilities and Walking Mountains and other groups. And so a lot of discount support on your cost. So notice your initial cost here over just going out and replacing your furnace is a few $1,000s, $4 or $5, maybe $6,000. I'm saving a couple thousand. So less than 3 years, I'm going to get my money back. Now, one could say, even if I go more conservative on these numbers, it's clearly less than 5 years. So it's really, really worth it, all these advantages. And if you want cooling in your system, it's almost a no-brainer, because why would you put a one-way air conditioner? And so with natural gas, it's a very similar situation with one. So the big difference is, even though natural gas prices are going up, it's still a lot less than propane. Pure electric, though, heat pumps are still favorable in operating costs, and you'll see that on the next slide. But the beauty is here is, if I have my heat pump system, and let's say my designer designs it so the heat pump can work, I might set it up here and say, oh, my heat pump, I'm going to set it up around 15 degrees. I'm going to have heat pump do all this. I'll have the gas supplement here. If gas gets a little more expensive, I can, if it's sized up right, I can push it down and I can rely less on the gas. If gas gets a little cheaper, if I'm not so worried about emissions, I can move it. So you've got 2 heating systems, so you can really hedge, which is really advantageous. And so this is the furnace. The heat pump with the electric's a little bit more, but this used to be a lot more. This is dramatically closer. And notice if I put these two together right now, this is at about 15 degrees. It's a little bit less. And you're going to reduce your gas use, for those of you, that's important, or GHGs. Those are the 2 big advantages. The costing is very similar to what I showed before with these big rebates. Obviously, if it's against AC, it's a lot less. If it's just a furnace replace, you're putting 2 devices in one, you are going to pay a little bit more. You're not necessarily going to get your money back very quickly, but you have all these other advantages. So that's the story on the natural gas side of things. So the key thing is getting a really good system, because, the high country of Colorado is a pretty harsh climate. And there's there's ways to avoid errors in heat pump, and avoidable heat pump errors. I should also say a way to do things right. We're going to talk about what's a cold climate, how do you make sure you get the right size, and a contractor and quality. So these are going to be some things to think about, have in your back pocket as you're looking at contractors and bids. So these are some of the things that have happened in the past, and they don't happen as much now. They're not going to happen to you. It's not a cold climate heat pump. Remember, there was this time where normal heat pumps, cold climates, and so you wouldn't have the capacity. It's not sized right. There's something called manual J, which is used for all heating and cooling sizing, not just heat pumps, furnaces, air conditioners. So that's the tool used by the industry. You got to make sure it was design temperatures right. You've got your climate zone 6 and 7. The result would be undersized units if this wasn't done right. And the other thing is poorly installed systems. So, you might hear, well, they're not going to work when it's super cold, or the heating costs were much more than expected. That's because something was not done correctly here. So number one importance is, how do you know you're getting a cold climate heat pump? And we talked about this thing, heating season performance factor, where most of the manufacturers, the good cold climate heat pumps are. And so these, if it's HSPF of 10 plus, SEER 18 plus, 90% chance it's a cold climate heat pump. Has to have a variable speed compressor. Basically, without that, it's really not a cold climate heat pump. They'll say they operate at temperatures below 0. Talk to your contractor. Every contractor works with 2 or 3 manufacturers, and they know the heat pump cold climate models. And you want to check that it meets utility rebate requirements. Up here, Holy Cross and Walking Mountains and all the groups have worked together, and actually all the groups in Colorado, to ensure that utility rebate requirements almost guarantee that it's going to be a cold climate heat pump. So you might go out there and look around some examples. If you go on Carrier site, you're going to see Infinity with green CBD intelligence, American Standard, AccuComfort Platinum 20, Bryant Extreme. So you're going to see these names: Extreme, really cold, and here's a variable speed heat pump example. So notice 20 SEER, HSPF 10, climate tough variable. Those are all hints. Yeah, that's a cold climate heat pump. A couple other things I'll talk about a little more detail in some subsequent slides about making sure you're happy with the noise of the units, and talking about the warranty, and particularly making sure it's got a very good warranty on it. So this is similar to the slide I showed a while ago. And so what the contractor does is they're going to run a manual J, and they're going to get this green line. The green line is, well, how much heat does this house need? And then they're going to take their series of heat pumps from their manufacturer. This is the old one. That wouldn't work. This one wouldn't work. And they're going to find out which heat pump can match this green line somewhere in the 20 to 5 degree range. So they're going to try to find the size that fits in there. So it's going to really do 80% or more of your heating. And then what happens when, they work cold, so they'll switch on and off. The smart controls will be in and go, all right, I can still do heat pump at 0, heat pump, heat pump, heat pump. Oh, let me put a little bit of supplemental on, a little supplemental electric heat pump, or let me shut the heat pump off, put a little gas. So the intelligence is very good in the system. Let's talk a little bit about terminology, because you're going to get your quotes and you're going to see all these numbers, and the contractor's going to talk about stuff. So BTU per hour is how much heating your home needs. That's this line, BTU per hour. And they're going to, at each city, there's a design temp. I think at Eagle, it's like -6. Doesn't mean it never goes below -6. That means it only a few hours below. So there's a proper design temp. And then you're going to get how much heating your home needs at that design temp. And then they're going to match a heat pump. Now, tons is 12,000 BTU per hour. So it might be, 48,000 BTUs, a 4-ton unit. That's what they're going to say. If you look at the model numbers in their quotes, somewhere in there, you're going to see one of these numbers, 024, 030, 642. And so that way you'll know. I mean, even if they don't say 4 tons or how much, you'll know how much it is. If your home load is between two sizes, so if you're in here and it's like, well, I can do one size and match it kind of here, or I can do another size and match it here. When in doubt, go for the bigger size. It used to be that people worried about oversizing, but these are variable, so they're very smart. And they'll run however much they need, but you want to make sure you got the right size. And honestly, all contractors, when in doubt, will make sure they got the good size. So in design, what you can ask them is, all right, you run the manual, Jay, what prices do you use for electric, natural gas, and propane? Where did you get them? In fact, you can do that. You can pull out your bills from the last winter and provide them to the contractor, and it has those prices, so you'll know for sure. And then how much does it use the supplemental heating? What does it switch over? Really, it needs to be that the heat pump can do it to 20 degrees or less. And then, how much heating is a supplement, and they can show you that stuff. So take a little pause here for a second to emphasize the duct system stuff is very important. A lot of you might be in older houses when there wasn't as much emphasis. The standards were a little bit less. And so now what you want to think about, I'm getting a new furnace. Is my house really comfortable? Is it good? Is the upstairs, is there a section that's too cold, basically? Or is there a section that's too hot, uncomfortable? You might as well get that taken care of. And so there's several things that can be going on. First of all, the ducts in the unconditioned spaces, crawl space, basement, they need to be well insulated, especially with a heat pump, because remember, the air temp's not quite as warm coming out of the heat pump. So you got to have good insulation. You got to make sure the ducts aren't leaking. If someone can't see the ducts, a lot of times in parts of the house, you might want to have a duct leakage test. And there's also, you should know, there are ducts rebates for duct sealing. They're available. A lot of times they're separate from the whole heating system rebates. So definitely check into those with the local groups. So what you got to do is ensure the duct sizing. They're going to look at the duct sizing for heat pump performance. Heat pumps typically need bigger ducts than furnaces because the temperature's low, but you're not going to go in and build a bunch of bigger ducts. All they're going to do is look at it and say, all right, I can add some returns here. I might add a little air supply here. And it's not too bad to do. The returns generally, they can be installed near the unit and just up in a little wall cavity here. Maybe you add a couple supplies in the second floor. And occasionally they might add a trunk line. The other trick that really helps is zoning. A lot of your houses probably have just one thermostat if they're older. You can have a zone system, 2 or 3 zones. So typically you'll have a trunk going up to the second floor, and then you might have 2 branches going out to the main floors. So you can put in the 2 or 3 zone system where there's a damper in each of those zones. You've got a thermostat in those sections of your house. And when that section of the house needs heating or cooling, it will call. This way, essentially, you've kind of increased your duct size too. So zoning is a really good thing to talk to your contractor about. And then, ask them, what's your strategy? Are we solving comfort issues? Are we solving efficiency? Are we solving leakage? It's a great conversation to have with your contractor. So a couple outdoor installation tips. These units are a lot quieter than they used to be, but there's still a fair number of dBs, and heat pumps are going to run year round. So, if you hang out on your patio, don't set it right next to your patio or under a bedroom window. If you like to open any windows that you like to open a fair amount, maybe while it's running. Wall mount's really nice in your part of the world because it gets it up off the snow. You can see this nice one here. But the contractor will want to do really good vibration isolation. And even with that, I'm not going to put it on my bedroom wall. I'm a laundry room, that's fine, or a hallway or something like that. So just think about that. Um, in terms of location, you kind of want to avoid strong winds. I mean, there is sort of funny in a way a wind chill effect. Um, what you can do is basically you can put like little shrubs around it or little landscape features if you have to put it on the windy side of the house. The southeast is really good. It's sunny, it helps with it. The north is kind of cold. Um, Snow and ice shelter, get it up off the ground at the right height. I mean, unless you want to warm up by going out and shoveling out your heat pump when it gets cold. And then these drain a little bit. So you got to have a drain. I don't have an example here, but I've seen somewhere they have a drain that goes on a sidewalk, causes icing. So just be careful about that and ask for pictures of installations. You know, here's a few you can see what's good, what's bad. Electrical requirements. A lot of time, so this is somewhat of a deal, but it's really not. It's just something you need to think about. So as you electrify, you're going to eventually may eventually need to upgrade your, this is not the right word, appliances. I got to change it. Upgrade your breaker. Typically, if you got a 150 amp panel, especially in an air conditioner, you can add in a heat pump and a little electric strip. Well, you can do that, or you can add 1 or 2 electric appliances. When you start to get full electric with all the appliances and the heat pump, et cetera, then you might have to go up to another panel size. But there are also rebates for panels, and Nikki from Walking Mountains had a great suggestion. If you put out a timeline, like you can plan out maybe 1 year, do your panel upgrade and have your rebates for that, and then add on, or vice versa. If you got a 100 amp panel, chances are you're going to have to upgrade. It's pretty old. The other thing about this little heating unit inside your air handler, it depends. When they design it, they're going to say how much sort of supplemental heating is needed. And these are different sizes. That's quite a lot of BTUs. So in the past, people used to just automatically put bigger units in. For example, it'd be like 10 kW, which requires a lot of amperage, but maybe you can get away with smaller ones. So just something to consider. Contractors, there's more and more, there's actually quite a few contractors really transitioning over to heat pumps. The groups in the slide at the end, there's a lot of local groups. They've got a great network going there. You can go to manufacturers' websites and see who's got the highest level of certification. Just simple things to do. Look at their websites, and they talk about heat pumps. Doesn't mean they don't do them. Sometimes, people aren't updating their websites, but if they've got all about heat pumps on their website, that's a focus of their business. You can talk to them, ask them how many they do, et cetera. On quotes, typically a lot of people get 3 quotes. It's quite busy right now. I'd say if you get 2 out of the blocks and they're pretty close, then you've probably know about where they are. But then if they're farther apart, you're going to get a 3rd quote. I'd be super cautious of low quotes, and what I mean is ones that are like 15% or less than the others. Good equipment costs money, and right now, good installers and well-trained, as unfortunately, the pricing is up there with all HVAC. And the online stuff, it's really not fair to compare. Just show you here. I've done this for many years. If I'm the contractor, I would talk to the manufacturer's rep. I'd go to the national manufacturer, distributor. If I had any issues at all, I could immediately get components, get advice from my distributors. Whereas, I've looked into this, and a lot of these folks, what they're doing is they just have a warehouse. They import the stuff in, and if a contractor wants to do it, they'll, get the equipment in. They'll go lower, but really, this is something you're buying for 15 to 20 years, an important piece of equipment for your home. So really, you want to have the gear there. I just talked to someone very knowledgeable, did his own, and he's like, yeah, my board blew out and I had to get it from Jersey because they didn't have any here, So just be aware of that. So let's just summarize here. Heat pumps work great in Colorado. You know, technology is just advanced. You've got a lot of benefits. Really, when you're replacing your system, you're doing it once, work with a contractor, you get the whole system right. You know, you've got some information. We'll send out the slide deck, some things about this. And really, if you find a good contractor, it's great. They're your teammate. A lot of stuff here I talk about, that's what they'll do for you. If you have any specific questions past this talk, you can always, this is my email. You can always email me. And here's a lot of great resources and folks. Nikki introduced me, and Mary's on the line. Lots of great folks to help you out. So that's about it. Any questions? I'm happy to take them.
Great, thank you, Dave. Much appreciated. We do have a few questions in here. First one, are supply chain issues currently impacting the equipment needed to move to heat pump systems?
Yeah, to some extent. It varies. It seems like every manufacturer does have heat pumps available. I would say, you know, I'm working with a few customers. They're getting quotes. I would say it might be impacting the mini split folks a little bit more than the ducted folks, because I think a lot of those are still manufactured in North America. But people are getting quotes and they're able to get them installed. And what I recommend is, what I typically have is people, I give them a list of contractors and they have different manufacturers. So, you know, if you go to a couple manufacturers, they might not have the ideal system, but 3 or 4, if you go to 4, chances are 2 to 3 of them are going to have equipment. And just plan ahead. Like, I wouldn't wait till this winter. Now's a good time to start getting quotes. Quite honestly, now's a great time to get some quotes. And then plan on getting them in. You know, if the equipment is 8 weeks out, you're in good shape, or 10 weeks out.
Unless you want it for air conditioning, Dave, which is why our contractors are really busy right now.
Yeah, unless you want it for air conditioning. Right?
Yeah.
So, yeah. So I'll just add to that the supply chain issue, Mitsubishi is one of the most popular brands, and they are definitely seeing some supply chain issues. So as Dave said, if you're thinking about getting the heat pump, the sooner you start getting quotes, the sooner they can start putting their name on equipment. And there are some contractors, both Walking Mountains and Holy Cross have contractor lists on our website. A lot of them are the similar, but you can go to both of our websites and get a list of contractors. Some of them have stockpiled some of the heat pumps, knowing this was coming down. So.
Yep. Yeah, and that was the next question. Can you make recommendations for installers? Yeah, if you go to the Walking Mountains website or the Holy Cross Energy website, we both have recommended contractor lists available.
And I would also say, sorry, Diego, that both Holy Cross and Walking Mountains, you can either do Diego or myself, or both of us, send us your quotes. We'll look at your quotes, because like Dave said, I've seen quotes from in the 20,000 up to 40,000. So there's a big difference out there.
And I would also, you know, really talk to the contract. I mean, have them tell the story, what they're thinking, what they're doing. They'll give you a really good idea, because you know, the ones that really are into this and thinking about making your house better, you'll get a lot of details from them.
All right, thank you. Next question. You said you expect a leap in heat pump capacity in the next couple of years. Would you wait to install a heat pump system until there is that leap, or would you do it now?
How old is your furnace? That would be my question. If your furnace is more than 15 years old, I would do it now. If it's less than 10, I would not do it now. If it's between 10 and 15, I think it depends on if you have issues in your house, like if you're just not happy. Well, okay, if it's propane or electric, I would do it now, right? I mean, I would do it right now, because you're gonna be saving money in 2 or 3 years. I mean, when I say a leap, what will happen is that HSPF typically will go up by 2, so it'll probably go from 10 to 12, which means, yeah, I might get, you might get another 15%. So if it's gas, if it's propane or electric, I would do it now. If it's gas, if it's over 15 years old and you really want to do that, then I would do it. If it's between 10 and 15, then it depends, do you have comfort issues, etc. The other thing is the rebates are really, really good now too. So that's another thing to consider. I don't know how big Mary's piggy bank is, but right now she's got a they got a really big piggy bank. So
yeah. And these are all good questions, because there's also one in the chat about with the future technology advancement and the quantum leaps, and is it a good time? So I'd also ask yourself, are you going to look at cooling? There's been a heat wave throughout the whole world almost. And if you're at the point where you have to have cooling now, then it's a great time to do the heat pumps too. It's not just for heating. And also to remind everybody that natural gas or gas prices, they went up. I heard from Black Hills that they tripled their gas rates. And then I believe Excel is going up, I think before I went on vacation, 14%. So if you didn't already see the effect of your gas bill last winter with Black Hills and Excel, you will definitely see it this year too. And then Dave, just one thing you didn't touch on, the only bigger technology thing, and it's not a big thing, but the refrigerant is changing. R410A is being phased out this year. And so there's going to be a new lower global warming potential refrigerant. And I don't know how that would really impact the heat pumps.
Yeah, I mean, if you've got an old system, I wouldn't wait. And if you have propane or electric, I wouldn't wait. And if you really need cooling, then so if you really need cooling and your furnace is not old, you can add a heat pump to that. You just have to make sure it's kind of the same level. So that's a little bit different story. If you got that situation, you probably should, we can talk about it.
Thank you. Here's a question from the chat box. Why not go all in with a full heat pump system rather than a hybrid? The 2 reps coming to my home suggested a hybrid, as they said the technology was not there yet.
It's really your preference. Some people want to totally get rid of gas, and others feel a little more reassured about that. You really just need to make sure it can size right. So I'll give an example where it could be tricky. So if your house is such that you need more than that 5-ton, so I had an example, 60,000 BTU. If your house is bigger and you need 75,000 BTU or something in one system, you're not going to get a heat pump that can do that much. And so what will happen is the heat pump might be able to do your capacity at 25, and then you're going to be a lot more dependent on electric. So in those kind of cases, I might go with a hybrid heat pump gas system. So there are some cases where it makes sense to do that. But in a lot of cases, I think it's just personal choice. Do you want to go totally without gas, or do you want to have gas as kind of this dual fuel way to go where you can sort of use more of one or the other? But if the contractors are telling you that, that will be one of the situations where they would say that. But
that's just that could be the contractor not having confidence. So I will say that I see more of that hybrid system in the Front Range being installed, which is kind of interesting because the temperatures are warmer down there. The ones that I have rebated have pretty much been 100% electric, and they add like a 5 or 10 kilowatt electric resistant backup. But you have to have confidence, and we know that they work. We have seen them work at -20 in our territory. So it's
if you want to talk a little more offline, I'd be curious, your situation of your house and why they're advising you that. So if you want to send me some details, we can chat about it.
Okay, thank you. And I'll also add to that, that in order to qualify for our rebates for heat pumps, the heat pump needs to provide the majority of the heating load for the home.
Right.
Or for the space.
Right.
All right, so next question. We have a radiant floor heating with a natural gas boiler. In addition, we have a ducted central air conditioning system. To replace all with the heat pump, would we need to install two separate systems with two outdoor units, or can we combine all with just one outside unit?
You can't do all with just one. The technology is really not available here. Okay, so it depends. Like if your boiler's in good condition, off the top of my head, without like looking at it a little more, I would say I would replace the air conditioner with a heat pump. I would use the heat pump to heat the house for the fall and the spring, and sort of till the clocks change. And I would start to use the radiant in-floor as in-floor comfort system as opposed to a heating the house system for those fall and spring seasons. So you've kind of got the best of everything. You've got your cooling. You're using efficient heat pump, very efficient times of the year. It's going to take a fair amount of load off the natural gas, yet you're still going to have the comfort of your radiant floors, and you're still going to have the capability when it's really cold. So off the top of my head, that's kind of the initial plan I would go after.
Okay, thanks. Next question. When retrofitting an existing natural gas forced air furnace, would it make sense to try and utilize existing ductwork or instead go ductless throughout a house? For instance, a 2-story, 4-bedroom house.
I would use the existing duct system, but I would spend a little money. Okay, so if your house is fairly comfortable now, it's not an issue. If it's kind of uncomfortable, the first primary strategy, use the existing duct system, improve it, put in some zoning, maybe put in better returns, etc. That would be plan A. There are cases, and I'm working on some houses now, where the duct system is such that it's really impossible to make the second floor comfortable. They're kind of these tri-levels, and so in that case, what we're doing is going to a mini split for the second story, and then truncating that vertical duct, and then getting a smaller heat pump system for the main floor. It's going to work really well, but admittedly, it's not an inexpensive strategy. So I'd really talk to the contractors, and there's amazing amount of stuff you can do with zoning. So that would be my first approach.
All right. How do you know if the ducting for the furnace system is the right size for replacing a furnace with a heat pump?
Well, that's where you're going to talk to the contractor. Notice that I didn't say, so if I'm building a new house up there and I have to design, and so like that manual J will say -6. So figure out what that house needs at -6. If I'm putting a furnace in at -6, I need a certain size ducts. If I put a heat pump in at -6, I would actually need bigger ducts because the temperature is lower and the BTUs, you need more BTUs. So the better designers are gonna, and so you know how I'm saying 15 to 20. So basically it fit around 15 to 20 in that range. The ducts are going to be big enough to carry enough BTUs from the heat pump to do the house. And that's why when you start to get below that, because you kind of have duct constraints, all of a sudden you're going to supplement it with either electric heating or go to your sort of gas situation, because those are higher temperatures. So there is kind of this balance, you're a little bit constrained on the ducts. The other advantage, though, is that's why zoning does kind of help, because So for example, if you end up housing 3 zones, 1/3 of the house, now you can kind of apply a higher BT, your heat pump it can apply sort of total BTUs to that part of the house. So the better design contractors will, and they'll probably talk to you about it. They're going to say the ducts can only carry this much, and it should be around 15-ish degrees or 20 degrees in that range. Complicated answer, unfortunately.
Great. Thanks.
But
Sounds
you
like
can,
it's a
Dave, you
contractor
can
question.
pay, because most contractors, you can pay, they're not going to do a static test on your ductwork or look for leaks. You have to pay extra for that. So would that be a good time for you to say, hey, can you really look at my ductwork, see if it leaks, see if it's the right size, and do some static
Yeah.
testing on it and pay? I mean, it could cost, up to, I've heard like $600 or something. Isn't that right? So can't you actually
You can look
test
at
the
that,
ductwork?
yeah. And like I said, in the talk, with a lot of the existing duct systems, they didn't put enough returns in.
Mhm.
And returns are easy to put in because they don't have to go to each individual room. So it's kind of easy to add returns, and that really helps the flow. And then I found we used to, often all you have to do is add selectively, especially in the second floor. It's kind of easy if it's up in the attic to add a few supplies. That's not an issue. If you got a finished basement, then it's a little bit trickier. So there's ways to do things with the ducts that are very reasonable. I mean, they're not going to be free, but given what you're doing, you might as well make it right.
All right. Can a ducted system be combined with a mini split? My second floor is not ducted or heated in any way, but it has attic access. And then, sorry, continued question. Is it using the same heat exchanger, or does it need to be separate units?
You can do it with Mitsubishi. And I think Daikin. In fact, that's kind of one of the ones in one of the houses. So Mitsubishi makes a multi-zone mini split system, and they have an air handler, a full-size air handler. So what you can do then is out of one outdoor unit, you can put this air handler to replace your furnace for the bottom electrical, and then you could have a mini split indoor unit upstairs. There's a couple of approaches to that. Definitely should ask for the slide deck on the mini splits, because what you can put in your second floor, these sort of mini slim duct system that can do a few rooms in your second floor. So yeah, with Mitsubishi, and I think Daikin has that. So that's kind of the latest, and that's actually really a really cool strategy.
All right, thank you. And so we had I guess a follow-up question. So from the question about trying to utilize existing ductwork or instead go ductless throughout a house, the follow-up would be coming from the standpoint of duct loss concerns versus the convenience of utilizing existing ductwork system.
Well, I guess, the question, if the ducts are insulated and sealed pretty good, then they're going to work fine. I think in your case, if your house is really uncomfortable in the sense it's a terrible, terrible duct system, you could look at the mini split. Realize the mini split strategy works really well, but you got to try to, that's the whole other talk, you got to try to minimize the number of heads. So like if you have a house with, like, let's say downstairs you got 5 main rooms, like you got a kitchen, dining, living room, family room, office, they're all heated by a duct system. You might need 2 or 3 heads on mini splits to do that. So it can be tough. I guess the simple answer is if you suspect that your duct system is horrific and just not going to work well, then, yeah, you consider going to an all mini split system. But I would say in most cases, duct systems can be made to work pretty well with a little effort.
Yeah, that's definitely what we're seeing here. So they're using the existing ductwork, or I've even had some people put in ductwork that were.
So I can even
No-
show people here. Let's see. I'll show you one really quick slide I'm talking about. Can you see that, Mary?
It just has the heat pump and Senazen
Oh, all right,
educational info.
hang on, everyone, just a second. I'll show you what I'm talking about so people can understand. So see this unit here?
Mhm.
So that's
Yeah.
that's like the full size unit. So in
Right.
some strategies, you can put that with the existing duct system, and the person who asked about their second floor, then they could actually put one of these up in the attic. So you have a combination of like this and one or two of these. So you've got a lot of flexibility in how you approach it with these, but it's a really very rare case where I would totally abandon the duct system. Very, very rare case.
Mhm.
Let me go back and put the help back up again so people can see that.
Okay. Great. Thanks for answering all those questions. Does anybody else have any other questions? Feel free to raise your hand. I can unmute you or go ahead and put them in the Q&A.
And these all help. And if people want, their mine is on there too. So lots of people can give you a hand working through stuff.
Great. Well, sounds like we don't have any more questions. So thanks again, everybody, for joining. Thank you, Dave
Yeah.
and Mary, for
Thank you.
for helping us out here. And
Yeah.
we will be sending out the recording of this webinar probably later this week or early next week. So just be on the lookout for that. We'll also include some information about our rebates, as well as information about future webinars that we'll be hosting about heat pumps in various different settings. So thanks again, everybody, for joining, and have a great night.
Yeah, have a great evening.
Great evening,
All right,
everyone.
thank you.
Mary, get some sleep.
Yeah, no kidding.